So I found this nice paper that just came out literally on 8th September, and I just found it. It's called Future Vision for Autonomous Ocean Observations. I added it here for, of course, giving you a sense of how the ocean may be monitored in the coming years and decades. Plus, the other thing, my own advice. I'm old enough to give advice now, is that climate change, whether we want to accept it or not, whether we want to be skeptical or maybe end up denying things for some, I don't know, I hope not, but it's going to affect, it's already affecting everything around the world, right? Food, water, energy, health, and everything else kind of fits into it. But so whatever career you pick, let's say you are watching this because you are still learning, you're trying to get into maybe engineering, maybe physics, chemistry, math, biology, maybe medicine, maybe journalism, maybe law. Everything can have a climate change angle, as I said, in various contexts before. So being aware of climate can help you contribute to the solutions or be a more conscientious earner of your living, whatever that means, right? So let's just look at how technology is being used to envision how ocean observations will be done. So on land we have what we keep calling now IoT, Internet of Things, which is already happening, where the phone is connected to the car, to your house, your air conditioning, your heating, paying bills. So there is this web of linked systems, which is called the Internet of Things. So the ocean monitoring is very critical. Atmosphere monitoring is critical, and land monitoring is critical as well, but this is an oceanography course, so focusing on the ocean. In general, the observations in the ocean are difficult because it's deep, dark, away from land, cold, miserable in the Arctic and Antarctic, and in the mountains, and so on and so forth, right? But how are the evolving technologies going to help us with the future of monitoring? So remember, detection and attribution. You cannot do effective detection unless you have really solid data. And the longer the time series, the longer the observational time series we have, the better we will be at detecting changes, right? Like sea level from tide gauges, we have some records that are longer than 100 years. Indian monsoon is longer than 100 years. Sea surface temperatures are reconstructed back to the industrial revolution, beginning of it, and also beyond that to a millennium. Accuracy and uncertainties begin to increase and so on. So looking into the future, we want to be able to generate as good a time series as possible for all the important variables related to climate, humans, and human-climate system interactions, or natural human-system interactions. Okay? So this paper basically puts out some exciting ideas, so I'm just going to run through them, not very detailed. This is a depiction of many autonomous and remote sensing platforms that comprise an ocean observing system. So there is a project called Nexos which is envisioning this. So you can see there are satellites, there are underwater gliders, and even the mammals and fish have been instrumented. So there are seals and dolphins and other things that keep doing the dives, and they have been instrumented with videos and temperature measurements, pressure measurements, oxygen measurements, and they produce data, right? So awesome. There are moored buoys, which we saw, I think, in the context of El Nino. You can go online right now and find out what is the temperature in the middle of the Pacific in the last hour, right? So those are from these kind of moored buoys. There is the Argo Float we talked about, which is parked at depth to avoid biofouling, comes up every 10 days and beams data, takes data along the way, goes down, takes data, and stays there and comes back. It has revolutionized ocean observations. There are bottom observations. There are cables running across, and also cables laid in the past that are being used for various things. So you can just look at all these things here, and there are more specific things like a sail drone deployment in Norway. We talk about drones now, Amazon doing drone delivery, drone photography, exciting nature documentaries done with drones, drones being used for bad purposes, for spying and dropping stuff that shouldn't be dropped, and so on and so forth. But you can see that it's got a little solar power, so it can be out there on its own, collecting data and beaming data either to the satellite or recording and then bringing it back. This is a real thing. Here is a blended wing glider as part of something called Robex. So these are real things, not just concepts. So you can see that this is a very nice aerodynamically shaped object that has lots of instruments on it, and it can just go around, can be navigated from land. So as a PhD student, you could be sitting in a lab on the coast and controlling your gliders out there in the ocean, collect data and bring it back, and then do your exciting research. Here is a Stone Aerospace's Artemis vehicle being launched through a hole in the ice into the Antarctic Ocean. Remember what we said before, Antarctic Ocean has a huge data bias because ships go there only in the summer. It's too stormy and too dangerous to go in the winter months. But if you have these kind of machines that can do it all year long, then this is going to revolutionize our understanding. So there are things called process understanding. So you want to understand, for example, how the circulation is changing, how the warming is penetrating the ocean, how that's affecting the shelf ice, and how that's affecting the air-sea interactions, etc. That then can be used to improve the models to enhance what is called predictive understanding. So process understanding is always critical for improving predictive understanding. And going back to the first chapter, the more data you have, the more hypotheses you build, and then you get more data to build theories and then build predictive models, right? So we are still ignorant about many things, so obviously those are important. Energy is obviously an important factor for all these. So candidate energy sources for autonomous underwater vehicles, AUVs, to recharge and offload nodes. So energy source, solar photovoltaic, offshore wind, wave energy, ocean currents, thermal gradients. Thermal gradients can be used to acquire energy, right? So you can go down with gravity, you go from warm water into cold water, and then you can use the thermal energy difference to come back up. So there are robots being built by small companies and big companies and individuals like my friend Yi Chao in San Diego, and Chris Zappa in Lamont Doherty Earth Observatory. There are many exciting scientists doing amazing things to do these instruments. Okay, primary source intensity is given here, conversion efficiency is given, benefits, and of course there are challenges. Okay, so here is a schematic of a conceptual description of cooperative network of AUVs, autonomous underwater vehicles. Then you can see that there is multiple instruments floating around, and they're communicating with each other. So they're kind of, let's say you want to track a school of fish. Okay, so you can have multiple autonomous vehicles communicating with each other and saying, you go there, I see something here, you come back here. Or you're trying to track a hurricane, or you're trying to track a marine heat wave, which is a serious problem now. I didn't talk much about it, but marine heat waves are becoming more and more common in some places where the warming is happening. Remember the warming patterns we saw? And of course, we are always learning from the species that live on the water. This is called a sheer water vehicle concept, which is using the physics we can learn from birds which kind of cruise very close to the water and increase their efficiency by reducing the drag and increasing the lift and so on and so forth. So many nature-based solutions exist. Okay, so really exciting stuff. So whether you end up doing physics, chemistry, math, biology, journalism, medicine, law, whatever, you can contribute by following up on your passion. You don't have to be stuck in particular direction, and it doesn't matter what your background is. You can use it for building some solution if you're aware of what the problems are and what the technologies are that can be applied to develop solutions. Future is bright. It's climate change is a challenge, but it's also obviously an opportunity, right?